So to review what we were talking about today in class, different solving techniques for problems that don't look like traditional quadratics. Remember, the idea is we want to turn these into equations that we're more familiar with solving, and we're really focusing on the factoring portion. So just a reminder about what we were talking about today is if you, first off, we have to set this equation up like any other that we've tried to solve. We've always had to get 0 on one side of our equation. So if we get x fourth minus 13x squared plus 36 equals 0. Remember, we talked about today was the substitution method. So we look at our middle term here, and that tells me what I want to substitute in for another variable to turn this into a problem that looks a lot nicer and something that I can actually factor or approach solving in different ways. So I'm going to turn this x squared into a u, and we talked about x to the fourth becomes u squared. So this is all just a reminder from this morning. We can then, now we have a quadratic equation that we can actually factor. So if we think about what adds to be 36 and, or sorry, what multiplies to be 36 and adds to be negative 13, oops, and we use u, not x, this becomes, well, negative 9 and negative 4 for our quick factoring. Tomorrow we'll review factoring in general to make sure we're all good on this. But when we factor this, we can then say, okay, I guess it's the power to say, well, u minus 4 equals 0, or u minus 9 equals 0. And now if we plug back in x squared, we can figure out what x is. We just need to remember we're trying to find what x is, not necessarily what u is. So x is plus or minus 2. That's 2 of our answers. Remember, we expect 4 answers. If you look up at the top, that fourth power tells us to expect 4 answers. U equals 9, so x squared equals 9, and then we take the square root. So x is positive or negative 3. Those worked out really nicely. Notice now we have 4 answers. Positive 2, negative 2, positive 3, negative 3. Well, substitution isn't going to work on every single problem we approach. So something that looks like this, we're still looking to factor. We're still looking to make it a problem that we can factor. So if we are going to factor, we still have to follow the same basic rules of getting equal to 0 on one side. That has to be your focus. You have to get equal 0. So if we subtract 12x squared from both sides, get 4x to the fourth minus 12x squared equals 0. Our factoring rules, whether we're dealing with quadratics or whether we're dealing with fourth power, third power, whatever it may be, still apply. First thing we want to look for is a GCF. So what can I take out of both of these groups? Well, 4 is in common and x squared is in common. And you say, what's left? Okay, well, 4x squared times x squared would give me back to 4x to the fourth. 4x squared times negative 3 would get me back to negative 12x squared. Our rules are the same. We try and factor, and then we see, okay, can I factor this piece? No. Can I factor this piece? No. But what I can say is, okay, these two pieces are being multiplied, so either 4x squared has to equal 0, or x squared minus 3 has to equal 0. So we use our factoring rules, GCF, and then see the remaining result. What can I factor out of that? Well, it's nothing, then I keep going. So divide by 4 here, we're going to figure out what x is. X squared is 0. If I take the square root, remember we generally do the positive answer and the negative answer, but for 0, there's no such thing as positive 0 and negative 0, so we kind of just say 0. And 0 is actually what we would consider to be a double root. Because we can't say positive and negative, it's going to count as 2 different roots there for us, but it's really just the same number twice. In our second set, we said equal to 0. We're going to add 3 to both sides. X squared equals 3. And then when we take the square root, so we take the positive answer, square root of 3, and we also take the negative answer, negative square root of 3. So x is 0, root 3, and negative root 3. Notice that negative sign's outside the square root. We're not saying the square root of -3. We're not saying an imaginary number. We're saying the negative of the answer that we got. So that counts as 4 answers because we had that double root because we didn't do positive and negative 0, which is kind of a technicality, but there's not really any other way to find another root. So using the GCF, we can factor. What if we get the only other way this problem might look? So we could substitute, we could use the GCF, see if we can factor anything that's remaining, or problem might look like this. So we're looking for 3 answers in this problem. And what's different about this, and we haven't done a whole lot of factoring this way, what's different about this is when we factor, oops, let's make that, put that in standard form. When we write this out, we haven't done a whole lot of factoring where there's been 4 terms. And we've done a lot of 2 terms, and we've done a lot of 3 terms, but when we have 4 terms, we actually want to do what's called factoring by grouping. It's we've seen 4 terms, but we just haven't recognized it's kind of in the middle of a problem. But factoring by grouping means we're going to group, as long as we've written it from highest power to lowest power, we're going to take our groups and we're going to factor each group using the GCF. So what can I factor out of this group? Well, x squared is in common. So hopefully this looks familiar as we move on here. And I'm left with 2x minus 3. In the second group, what can I take out? Well, there's a minus in both of them, so I'm going to take a minus. And it looks like both of those can be divided by 4. So this is 2x minus 3. So hopefully this looks familiar from other factoring we've done. We've just kind of used this as our intermediate step before. But if you see that repeat parentheses, one of my parentheses is 2x minus 3. The other is what's left over. So x squared minus 4. So x squared minus 4, that's a difference of squares. We can also factor that as x plus 2, x minus 2. And now we took a third degree polynomial and we've been able to factor it. Factoring by grouping is just a different method. So if we take each of our parentheses, 2x minus 3 equals 0, x plus 2 equals 0, and x minus 2 equals 0, we can figure out what values of x we have. So if we add 3 divided by 2, x is 3 halves. If we subtract 2, x is negative 2. If we add 2 to both sides, x is 2. So my answers, I have 3 of them. 3 halves, 2, and negative 2. So we will practice factoring more tomorrow. Come prepared to discuss these questions as well as the ones that we were left with in class.